SwayamPrabha. Digital India. Educated India.
Hello friends, I welcome you all to the Automation in Manufacturing course. So this is lecture 2 of week 2 and we will be studying various automated systems and equipment used in the manufacturing. The outline of the lecture is as follows. At the start of the lecture, we will study the meaning of flexible manufacturing system, various equipment which are used in flexible manufacturing system. We will see the CNC technology in little more details. We will understand the concept of CNC technology and its usefulness in the manufacturing by taking an example of vertical milling operation, which is widely used in the tool rooms in mechanical industry. So let us begin with the definition of a manufacturing system, that is a flexible manufacturing system. There are three types of productions being used in the industry: low production, medium production and high volume production. In medium production, there is a variety of components need to be manufactured and the volume of the production is in medium range. To cater the needs of such mid volume production, the flexible manufacturing systems are widely used in the industry. The flexible manufacturing system is a production method that is designed to easily adapt to the changes in the type and quantity of the product being manufactured. So as I mentioned, this is the best suited manufacturing methodology for mid variety, mid volume of the production, so that it can easily adapt the changes in the type and the quantity, in the variety and in the quantity of the product that to be manufactured. So it is best suited for batch production, so which is having mid variety and medium volume. So medium variety and medium. So in general, a flexible manufacturing system has many equipment which are arranged in logical order that we will see in the next slides. So the equipments or the machines and the computerized systems which are part of the FMS, they are configured, they are arranged in a logical fashion so that a variety of parts can be manufactured to handle the changing levels of the production, to handle the changing levels of production, to handle various part families. Part family is nothing but a group of products which are having either geometric similarity or manufacturing similarity. Let us move ahead and look at what are various elements or what are various types of equipment which are the part of the FMS system. The first group of equipment or the first group of machines is the CNC machine. So CNC is nothing but computer numerical control machines. So this CNC technology is applied to various operations such as machining operation, turning operation, grinding operations, gear cutting operations and variety of other machine tools which are computer numerical controlled. So these are called as the CNC machines. So CNC machines can be called as the backbone of the flexible manufacturing systems. Next group of equipment which are widely used which are important in FMS. These are material handling systems. So, material handling, we have to do the material handling of the component or the tools, or we have to even convey the raw material. So, material handling means it is the raw material, work in process, tools. So, tools may be the dies and molds and the maintenance material. So, all these are coming in the material handling system. So, to carry out automatic material handling, various types of equipment are used. So, these are rail guided vehicles, automatic guided vehicle and robots. So, RGVs, AGVs and industrial robots are used to handle the material. Even material handling also has the feeding of the component to the machine and then removal of the component from the machine, or we can say loading of the machine and unloading of the machine also comes into the material handling systems only. So, basically robots are used for feeding the work parts to the machines, loading the work parts to the machines and unloading the work parts from the machines. Third group of FMS equipment, auxiliary equipment. So, auxiliary equipment include pallet stores, load and unloading stations, tool storage or tool stores, presetting of the tools. Presetting involves taking care of the cutting tools. Tool presetting is taking a considerable time in manufacturing operation. If we can do this operation offline, we can save a lot of lead time in the manufacturing. So, that is why there are dedicated tool presetting stations are designed in FMS, where the tools are being set, they are getting ready, so that directly they can be utilized for actual manufacturing operation. Washing stations, the work parts which are processed, they are to be cleaned. So, we need to have a washing stations. Then measuring equipment. So, to check the size, shape, to check the surface quality of the processed part, we need to have a dedicated station where all the measuring equipment are arranged and the work parts will be examined there. They will be inspected to check whether the quality of the product is as per the desired specifications or not. The last and the most important component of the FMS is its brain, that is the central computer. So, central computer is controlling the operations of the CNC machines, material handling systems and auxiliary equipment. The computer has various softwares installed. These are simulation softwares and DNC software. So, DNC is direct numeric control. So, in this philosophy, a single computer is controlling the operations of a variety of machine tools. So, that is called as direct numerical control. Now, let us see how a typical flexible manufacturing system works. So, for that purpose, on your screen you can see a typical arrangement where the various elements of the flexible manufacturing systems are shown. So, these are CNC machines. So, here you can see CNC milling center, there is a turning center. So, this is also CNC operated, CNC turning center, CNC milling center. Then we are having the stores, but these stores or the storage system is automated. So, we are storing the components in an automatic mode and it has the automatic retrieval as well. So, the system is widely known in the industry as ASRS, that is automated storage and retrieval system. The conveying arrangement can be seen over here. So, in this FMS automated guided vehicles are used. So, the entire operations or the coordination among all these equipment will be done by a computer. All the operations will be controlled by a computer, that is the central computer. This configuration is typical, it is for the education purpose only. In industry, little more complicated or little more different configurations are used, and the configurations are varying from the industry to the industry. They are customized configurations, they are designed as per the need of that part family, as per the requirement of the company, as per the investment capability of the company. Well, I do have a video that I will be running now for you. You observe the video, you look at the video. So, that video will give you a glimpse how exactly the typical flexible manufacturing system works. Afterwards, we will see one by one what are various equipment. Well, on your screen you can see automated storage and retrieval system, and a crane stacker. A retrieval system is having a crane stacker. Now, this stacker has gone inside, it has taken the components that to be machined in the flexible manufacturing system. The components are taken, and now these components will be fed to the conveyor. That conveyor will take the components and it will load the automated guided vehicle. On the screen now you are seeing an automated guided vehicle. This automated guided vehicle is moving, it has reached to its destination, and from its top portion the components are now taken through the conveyor on automated feeding system. So, the first operation will be carried out on the CNC turning center. The automatic feeding system has taken the component that to be turned on the CNC turning center. The component has been taken and it will be feed to the machine. So, the machine has a 3-jaw chuck. So, automatic chuck is holding the component. So, it is pneumatic operated chuck. The feeder will leave the job and immediately the chuck will hold the job. The component is now held in the chuck. The machine door will automatically closed. The central computer will now give the instruction to the CNC machine tool to carry out the desired manufacturing operation. Here the turning operation means there is reduction in the size, reduction in the diameter of the axisymmetric parts. After machining of the work parts or after processing of the work parts, the same feeding mechanism will approach the work part, the chuck will open, immediately the feeder will hold the work part and it will safely unload the work part from the CNC turning center. The feeding mechanism will orient the work part in its original position and then it will put on the conveyor system. The conveyor system will load the finished or the semi processed work part to the AGV. The conveyor is moving and the pallet will come and it will get loaded on the top portion of the AGV. Now, the next work part will be processed and that is on the CNC milling center. Again, a specially designed feeding mechanism will approach the work part. It is approaching. This is pneumatic operated. It has taken, so it is holding the work part and will feed that work part to the CNC milling center. So, the milling center is having a pneumatic operated automatic voice, machine voice. Compressed air is used to hold the part. The vice is closed, the work part is firmly held. Now, the door will close as per the instruction given by the central computer through GNM code. The GMN code will get executed and then the processed part or the machine part will be ready for its further operation. So, the same feeding mechanism is approaching the work part. It has taken the work part. And that work part will be put on the conveyor for its further transfer to the automated guided vehicle. So, AGV is now coming back to the storage system for storing the finished product or the semi finished product back to their destination in the rack. So, all the racks are coded. So, here you can see the racks are C1 R3, C1 means column 1 and R3 is row 3. So, column 1 row 3 is the rack number. So, stacker crane is stacking the work parts at their respective destinations. Well, after this interesting video, let us look at all these parts one by one. The objective of this course is to design all this equipment. So, to design all this equipment, we first know what are their the utilizations in the industry, and then slowly we will look at the constructional elements in the coming lecture. Well, to understand the CNC machining center, I have taken here the example of a CNC milling operation. So, milling operation is a material removal operation in which we are using a hard tool. The hardness of the tool is much more than the workpiece, and we are having a relative motion of the hard tool, high strength tool material with the workpiece. So, when we are having a relative motion, then there is a shear plastic deformation of the softer material, and the softer material is workpiece. So, in this case you can see, so the hard tool is rotating about the z axis, and this is the work part, it is moving along x and y axis. So, on the screen schematically you can see the tool is rotating, and when we feed the workpiece along the z direction, then we can achieve that deeper cavities or deeper features. So, here the feature depth is controlled by giving the feed along the z direction in multiple number of passes. To have a broader features that to be machined, we have to give the feed along x and y direction. So, along x and y direction, if you feed the material, then we can generate the features on the surface that we called surface milling. So, this is called as the pocket milling. So, when we want to mill pocket by cutting along the z direction. Milling tools may have 2 fluids or 2 cutting edges, or it may have 4 fluids or 4 cutting edges. There are many tools, those who are having flat end, their end is flat, these are called as flat end mill. When the tool end is of ball shape, it is called as ball end mill. So, variety of such tools are used to generate various complicated surface using the milling operation. However, the conventional milling machine is having a drawback that we cannot manufacture very high level of surface finish. We cannot manufacture free form surfaces, and it is very difficult to achieve the accuracy or the resolution in microns. The reason is obvious, there is a human intervention and it is difficult for human being to control the feed that to be given to the workpiece. A typical conventional milling machine is seen on your screen. So, it has a work table. On this work table we are mounting the workpiece. There is a spindle. On the spindle we are holding the cutting tool. On work table there is a clamping voice. In the clamping voice we are clamping or we are fixing the workpiece. The work movement is manual, and this manual work movement will be carried out by the control wheels and the handles. The spindle is rotated by a DC motor, and various speed levels can be obtained by using a gearbox. So, you set a spindle speed here, and then you can have the relative motion of the tool with the work part by rotating these hand wheels. So, it is very difficult for the human being to have a proper feeding of the workpiece by rotating the wheels in a consistent manner. So, for that purpose we are developing the CNC based machine tools by using the various building blocks that we have seen in our previous class. So, the CNC machine tool is solving or it is overcoming the limitations of a typical milling machine. How? The work table movement here it is automatic. So, we are developing a machine tool with automatic movement of the work table. So, for that purpose we are using the precise lead screw arrangement and these precise lead screws are being driven by the servo motors. In conventional milling machine, the tool changing is manual. So, that takes lot of time. Presetting, as I mentioned, is also a time taking. So, in CNC machine tools, the tool changing is automatic, which is saving lot of lead time. Automatic movement of the spindle along the z axis. So, the tool is moving along the z axis, automatically. The safety operations are there, door on and off. Then auxiliary operations like coolant on and off, all these operations will be carried out in a automatic mode. So the CNC machine tool has a controller or the brain. The microprocessor is nothing but a system which is having logic gates, memory elements, battery and some memory storages. And these microprocessors are working as per the instructions given by the programmer. So software we have to install in the microprocessor, or according to the instructions written in the software, the microprocessor is carrying out various functions. Processor basically generates the pulses that are needed to actuate the drive mechanisms. So in CNC machine tools, basically we are using electrical drives, electrical motors to generate the pulses. To drive these electrical motors, the microprocessors are producing the signals. In addition to that, the microprocessors are generating the signals to make the compressor on and off, to control the directions of various control valves. It is controlling the door opening and closing. So all these operations will be taken care by the microprocessor. So in this way we can improve the surface quality, we can enhance the capability of a typical conventional milling machine to generate very complicated shapes. So one example is there in front of you. On your screen you can see a turbine blade. You just look at the complicated shape of the turbine blade. Here all these are the blades, and these blades are thin, they are intact with its core, and they are precise as far as their thickness is concerned. The shape is so complex that it is very difficult, or rather impossible, by using a conventional machine tool to carry out this operation. So for that purpose, a multi-axis CNC machine tools are used, 5-axis CNC machine tools are used. So some more pictures that I would like to show you over here. So these pictures will give you the idea how exactly the CNC machine tools are operating. So in this picture you can see the workpiece is oriented in such a way that it is easy for us to carry out the actual machining operation. So here we are adding more number of control, more number of movement of the axis. We are adding more degrees of freedom that to be used to machine these kind of work parts. So it is not only the X, Y and Z that are being used. In addition to that, we are giving one more axis to the workpiece movement. In the third picture you can see the tool is inclined. So the tool is inclined to carry out the machine part. So the work part is fixed, it is not moving, but more degrees of freedoms are provided to the tool axis. So various configurations can be found in the industry. So many industries, they are coming up with the variety of the novel configurations to machine such the complex surfaces. Well, my friends, let us summarize the lecture. In this lecture, we have seen the concept of flexible manufacturing system. We have seen its definition and various automated equipment which are used in this system. We have seen in details about the CNC technology, the NC and CNC technology used in the manufacturing domain. We have seen an example of a vertical milling process at the end of the lecture. In the next lecture, that is lecture 3 of week 2, we will be studying the CNC machine tools in little more details. Various elements of CNC machine tool such as the tool magazines, pallets and palletizing, tool wear monitoring systems. We will be also looking at the adaptive control technology based machine tool concept. Then ASRS, a very useful utility, a very important utility that we will be studied. Then we will look at the industrial conveyors and the use of industrial robots.